Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
Hi there. In this video, we're going to talk about data joins. Data joins are really incredibly helpful whenever we want to start bringing multiple data sets together. So a lot of times you'll work with one data set individually and you'll do some manipulations on that, and that's really what we've covered up to this point. But a lot of times you need to join two tables together because there's information in one table that doesn't exist in the other, and so on. Lots of different reasons you want to do a join. So we'll discuss in this video right, left, inner, and full joins. There are different types of joins out there, but really you can do almost everything you need to do with a right, left, an inner, or a full. And a lot of times you'll use these, you'll get comfortable with one of them and just kind of use it almost all of the time. So let's just jump into definitions and examples. In this video, I just kind of want to give you a high-level overview of what each type of join is and does, and then in the next video, we'll jump into the R window and actually look how to execute joins, particularly in the tidyverse syntax that we've been using. So first up is an inner join. So an inner join keeps all observations with a matching key in both data sets. So we can see that here we have two data sets. On the left, we have 6 observations, and our data set is just name and age. So we have Tom, Dick, Harry, Sally, Susan, and Rachel, and their corresponding ages. And then in our second data set, we have Tom, Harry, Sally, and Gail, and their gender, 2 males and 2 females. And so what a join will allow us to do, you see we have age in one data set, gender in another data set, but we have this common key of name. So the inner join will allow us to keep all observations from both data sets where they have a matching key in each data set. So for example, you'll see that both data sets have name Tom, right? So we have Tom in both data sets. So an inner join would preserve Tom. It would also preserve Harry and Sally as well. So those are the 3 observations in each data set whose key of name in this case occurs in both data sets. So if we constructed an inner join, our resulting data set would have 3 observations, Tom, Harry, and Sally. We would see the corresponding age brought in from the first data frame and the gender brought in from our second data set. Okay, so that's an inner join. Keeps all observations with a matching key in both data sets. Now the next type of join is a left join. So a left join is going to start with your initial data set, and it'll keep all of the observations from this data set, and then it'll add your variables from the second data set only where a matching key is found. So what will happen here is that we have Tom, Harry, and Sally. So because the keys of Tom, Harry, and Sally match in the second data set, we'll be able to join gender as an additional column, but there is no matching gender for Dick, Susan, and Rachel, so their genders will just be left blank. And you can see the resulting data set here. See, gender is added as a third column. Tom, Harry, and Sally's genders are attached because we were able to perform a matching key. And then Dick, Susan, and Rachel do not have their gender populated. It's just a missing value because there was no corresponding value from the second data set to join on here. Okay, so we have an inner join, gives us observations with the matching key in both data sets. A left join starts with our first data set and then adds in the fields, populates those values where the key actually matches, and for all others, it just sets that additional variable to 0, or excuse me, to missing. Now, next we'll look at a right join, and a right join is going to keep all observations from the second data set and add variables where a match occurs. So a right join functions exactly the same as a left join does, except that the starting data set is your second one. So in this case, we'll notice the same matching variables of name, but here we're going to keep our resulting data set. We'll keep Tom, Harry, Sally, and Gail, but we'll only have we'll take age from the first data frame and join it onto here, and we will only have age populated for Tom, Harry, and Sally. And so we see that we get age with Tom, Harry, and Sally. Gail doesn't have an age because Gail doesn't exist in the first data set, right? And the genders are all populated because we started with the second data set here. So again, we get a missing value there where no match occurred. So that's an inner join, left join, right join, and then we have one left, which is the full join. So the full join keeps all observations from both data sets. So up to this point, with the inner, the left, and the right join, we've required a matching key in order to complete the join. We've keyed on the variable name. But in a full join, our resulting data set is going to have all observations from both data sets, and then it'll just fill in age and gender where it can find a key, and if there is no key, then it'll just set them to missing. And so we see here that exactly what we would expect. We see that we really start with Tom, Dick, Harry, Sally, Susan, and Rachel. We add Gail because she's needs to come over from the second data set. She's the only name not in the first one, so we need to add an observation for Gail. All of the ages are populated, and then except for Gail's because she doesn't have an age. And then all of the genders are populated from the second data set, except for the ones where there is a missing value. So you can see that this is really the opposite of the inner join, and it gives us all the observations from both data sets and just populates missing where there is no matching key. So a couple of takeaways for you to think about when thinking about joins. Again, anytime there's no matching key, you're going to end up with missing values. With the one exception being an inner join. An inner join, if there are no matching keys, then that just won't be in the resulting data set. So it would be good for you to go back and review each of these a little more carefully, pause the video, and make sure you fully comprehend which observations come from each data set into the resulting data set, and then why the missing values are in fact missing for each type of join. Hi there. In this video, we want to continue our discussion about joins, and we'll actually start programming some simple joins here in R. And to do that, we will use the tidyverse syntax. So I've already loaded the tidyverse package here, and then I've recreated our data frames from the last video as just df1 and df2. And these, you'll recall, have data frame 1 has name and age. So we've got Tom, Dick, Harry, Sally, Susan, and Rachel. And then data frame 2 has name and gender with Tom, Harry, Sally, and Gail in the data frame. So let's go ahead and start coding up some joins. So the first one that we'll do is an inner join. An inner join. And so in order to do that, we're just going to do, let's call it an inner join data frame. We'll create an object called an inner join data frame. And so the function that we'll call that's in the tinyverse is literally called inner join. Inner join. And so we're going to join data frame 1 and data frame 2. And then our by variable is going to be name. And we'll go ahead and execute that. And then let's take a look at what inner join data frame looks like. And so we see there the same thing we saw in the previous video where we have Tom, Harry, and Sally with their corresponding age and name. Age and gender. So you'll recall that the inner join is going to take both data frames and return the records where there is a matching key. And it'll join the columns together. So we had Tom, Harry, and Sally that were in data frame 1 and in data frame 2. And so whenever we perform the inner join, we get those three observations, and then the variables are all appended together there. Okay, so there we have our inner join. In general, general join syntax in the tidyverse is to just say you've got some sort of join. So it could be an inner join, left join, right join, full join, and then there are actually a few others that are outside the scope of this video. But you're going to inner join, so you're going to have data, let's just say data 1 and data 2, and then by some key, whatever the key variable happens to be for your data set. So that can get a little more advanced, and we'll cover some of that in the next video, but that's the general syntax, is that you want the join function, pass it which two data frames you want to join, and then tell it which variable to use as the key. So let's go ahead and do our other joins, let's maybe make a quick note here that we kept all observations with matching keys, right? And so now we can do, let's go ahead and do the left join. So we'll call it left join data frame. And that's going to be a left join of data frame 1, data frame 1, data frame 2 by name. All right, so we can look at our left join data frame. And you see there that we get all of the observations from data frame 1. So all 6, Tom, Dick, Harry, Sally, Susan, Rachel, all of their ages because those were populated. And then we get gender attached as well, but we only have the 3 genders populated for the 3 matching observations from data frame 2, and the others are set to missing, as we expect. All right, so then we can do a right join. And it's going to be exactly the same syntax, so let's call it a right join data frame. We'll call the right join function, and it's still going to be data frame 1, data frame 2 by equals name. So you can see that the syntax on all of these is exactly the same. We're just changing the function, changing the join function that we call. And so here we see the right join data frame 1, data frame 2. We're gonna keep the 4 observations from data frame 2, right? Tom, Harry, Sally, and Gail. And then we are going to attach age, but Gail's age is missing because she doesn't have a corresponding key in data frame 1. So we start with all the observations in data frame 2, and then we attach age for all of those observations. Since there wasn't one for Gail, it comes up missing. And then lastly, we'll do a full join. So let's call it a full join data frame, and we'll call the full join function, data frame 1, data frame 2 by equals name. All right, and we'll go ahead and look at that. And again, there we see all 7 observations. We have the 6 from data frame 1. We also join Gail from data frame 2, and then you see the corresponding populated or missing values based on which variables we actually had in the 2 data sets for each name. So very simple syntax in the tidyverse, very handy, compact syntax, very straightforward and intuitive as you would expect. Now, I do want to run through one more question. I want to say, what happens if we use a right join but switch data frame 1 and data frame 2, right? So let's just call this right join 2. And so we'll do a right join, but instead of calling data frame 1 data frame 2, I'm going to call data frame 2 and then data frame 1. So any ideas on what might happen? What do you think? You might want to pause and ponder this. What happens when we do a right join but flip the orders of the data frames? Let's see. We'll go ahead and run that. We'll take a look at right join 2, and what do we have? Well, this looks very similar, doesn't it? We have all 6 observations from data frame 1. We have missing gender for Dick, Susan, and Rachel. And then we have age, right? So which one of our data sets had all 6 observations, all ages, but some missing genders? Not the full join, not the right join. Aha, in fact, it was the left join, right? It was the left join. So when we left join data frame 1, data frame 2, it's almost exactly the same output as right joining data frame 2 and then data frame 1. The only difference we run into is the variables are put in a different order. And that's no problem there. You can rearrange variables very, very easily. So just an interesting, little example there that really with a right join and left join, you can accomplish the same thing using either function just by changing the order of your variables, of your data frames. But you want to be careful. You want to keep track of, like we've been doing here, our number of observations and and things like that. Do your missing values make sense? Those are all things that you want to look for. So if we do, just for example, a left join starting with data frame 1, then yeah, we would expect to see all of our all 6 observations, right? And then similarly, if we run a right join starting with data frame 2, then we get a similar result. Hi there. In this video, we'll continue our discussion about programming joins, and we'll continue looking at our some similar data sets that we've been working with. Now, I've loaded the tidyverse to continue our work, but I have updated data frame 1 and data frame 2 with a little bit of additional data. So data frame 1 now also has the person's position on it. So you'll recall that we had name and age before, so now we'll have a position. So maybe this is a subset of some personnel data or something like that. So we have employees and managers, and then in data frame 2, we have 5 observations now. We have 2 different Toms, so we have 2 guys named Tom. We have gender and age now. And you'll notice we can tell they're 2 different Toms because we have one Tom that's 35 and one Tom that's 33. So 2 different Toms, and we also have an additional variable here. It was just name and gender, but now we have name, gender, and age. So one interesting thing that happens already is that we have age in both data sets. Well, what sort of issues does that bring into play? And so we'll talk about that. So having some additional data like this brings up a couple of different things that you'll encounter whenever you're executing joins in R. So the first thing says, well, what if I want to join only certain columns, right? Join only certain columns. And so let me show you what I mean by that. Let's just call left join directly, and we'll call data frame 1 and data frame 2, and by name. Right? So what happens whenever we join data frame 1 and data frame 2 by name? Well, you'll recall data frame 1 has name, age, and position. Data frame 2 has name, gender, and age. Well, what happens then is that we keep our name variables, but you'll notice that we get this age X and age Y, right? Age X and age Y. And so what's happening here is that since age exists on both data sets, R automatically has to add an identifier to say which age column is that from, right? So X is going to be from the first data frame you mentioned, and the Y age is going to be from the second data frame that you mentioned. Now, we also see that gender has joined correctly. Tom is a male. Both Toms are males. Harry is a male. Sally is a female. Dick, Susan, and Rachel don't have a gender on data frame 2. Their positions carried over from data frame 1 just fine. Now, one other thing you might notice here that sort of became a complication is that Tom now occurs twice. So you'll recall in data frame 1, we start with all observations in data frame 1, and then we join these variables where there is a match. And so that's what's happened here, except that R has recognized that there's 2 Toms in data frame 2. Recall there's 2 Toms in data frame 2. They're both males, but one's 35 and one's 33. So what will happen in this case is that name is going to get, well, really the record in the first data frame is going to get duplicated. So you'll see that Tom, age from the first data frame, and position are going to get duplicated so that there's a place to put the gender and age from the second data frame, because R recognizes there's a unique or a matching key of Tom. All right, so all of this is going to be problematic. So we want to clean this up a little bit. First of all, let's deal with the age variables. So what we can do here is really we don't need to join age because age should be the same. Now we have this redundant Tom situation that we need to deal with, but recall we're trying to left join on data frame 1, right? So we want to just start with what's in data frame 1, so we don't need the second Tom. We don't know about him yet, right? So what we can do to join only certain columns is, instead of joining data frame 2 on there, we can join only a subset of data frame 2. So recall that to subset, we can use this bracket syntax, and we only want certain columns. We're only going to consider the name column and the gender column. So if we just run this piece of code, just this reference to data frame 2, you'll see what's happening, right? We're really catching, we have just the 5 observations without the age variable. So by using this subsetting syntax, we're saying that we don't want to join all of data frame 2. We only want to consider name and gender from data frame 2. Now, whenever we run this and use our left join, now we get our observations, and we don't have the 2 age variables, right? We don't have the 2 age variables. And so that's really what we were looking for. We already have age on the data frame, so we don't need to add it again, but our genders do populate. Now, you might also notice we still have this duplicate record for Tom, which is a little bit confusing. And so that's something you just need to watch out for whenever you're doing left joins, right? Because this could be a number of cases. This could be an error, in which case you just take out one of the duplicate records and move on with your processing. But in this case, we have a legitimate second Tom who's in our data set, in our second data set. And so we need to think through how you want to handle that. And so it would just depend on whatever business case or project that you're working on, whether or not you need this additional Tom record, or maybe you need to get a last name or something like that. The bottom line is that the key of name is not strong enough to differentiate the 2 Toms whenever you're executing a left join in this way. So it could be a combination of things. There's no one answer in terms of how to handle this second record. It's situation dependent. But it's just something to be aware of, that whenever you left join, if you get duplicate records like this, that could be one reason why. If you have one key in the first data set with multiple matching keys in the second data set, that's going to create additional records in your result. And so if you're looking for 6 observations and you get 7, you know that you've duplicated somewhere, and you just need to think through how to handle that. Okay? It could be a different join, or it could just be deleting the record, like I said, or handling it some other way, adding some detail or something like that. But again, just something to keep in mind. So be aware of that whenever you're processing joins, and that can happen with right joins as well. Now let's talk about what if we wanted to join with multiple keys, right? So since first name might not be a strong enough key, we hadn't really talked about that yet. For those duplicate records, first name wasn't a strong enough key, so it brings up the question, how do we join on multiple keys? So that's actually really straightforward. We'll call the left join function again. We'll left join data frame 1 and all of data frame 2. But now let's join by name and by age. By name and by age, and see what happens there. And so here you can see now that we've joined gender from the second data frame, right? We've joined gender. We don't have the additional age column because we included age as part of the key. So any variable you include as part of the key won't be added to the data set as an additional column. So we don't get the added age column, and we don't have the duplicate Tom column because we joined by name and age. And so we can see that our name, Tom, age 35, matches to, in data frame 2, Tom, age 35. So that's a unique key where it matches on both variables. And so we just add the gender of male for Tom, and we're good to go. But now we've got another curiosity in our data set here. Tom, Harry, and Sally should all have a gender, but now we have Harry's gender as missing. So we need to think about, well, what happened? Because I've got Harry over here in the first data frame. We have Harry over here in the second data frame. He's a male. So this should populate. We should get a gender for Harry. Well, recall that our key that we used was not only name, but name and age. So R is looking for a Harry who's 37 from data frame 1 and a Harry who's 37 in data frame 2. But there is no Harry who's 37. The Harry in the second data frame is, in fact, 32. So again, no one answer on how to handle that. It really just depends. It could be that his age, Harry, it's the same Harry in both data sets, but his age was recorded incorrectly in one of them. Maybe he is 37 and it's not correct here. Or maybe he is 32 and it's not correct over in data frame 1. Or maybe they're two different Harrys and they happen to be different ages. All of those would be viable scenarios, and you just don't know. So it would just depend on the situation you're in. Maybe, again, you can get some additional information, or you have a business rule that says always go with the highest age or something like that. You can develop all kind of rules like that. But just something to keep in mind that, we said here, okay, well, name wasn't a strong enough key. We're still getting these duplicate records, but whenever we used a stronger key, now we've still got a data issue. Even though everything else looks like this processed correctly, we still ended up with this weird missing value. So when you're doing joins, a takeaway here is that when you're doing joins, always keep track of your record count like we've been discussing to see if you add or remove records that you didn't intend to. And then also check your missing values because those missing values can really key you in on something. Are you getting missings where you don't expect? Are you getting populated values where you would expect a missing? That can also happen. So those are the two big things you need to keep track of whenever you're doing joins. All right. One other thing that we want to discuss in this video, we've talked about only joining certain columns. We've talked about strengthening the key and joining with multiple columns. And now let's talk about joins when the key fields have different names. So up to this point, we've had name and name, or name age with name age. But let's see what happens if the names are different. So I'm going to rename some columns in data frame 2 just so that we get different field names. So let's call, instead of name, let's call it title, which is kind of silly, but it's all right. And then instead of age, we'll call it years. All right, so let's look at data frame 2. We'll see that instead of name, gender, and age, we'll call it title, gender, and years. Right. So now we can't just say key equals name because in data frame 2 there is no name. In fact, let me show you the error that will get thrown if we try to join data frame 1 and data frame 2 by name. Then we're going to get an error, and it says we can't join because the column name doesn't exist on the right-hand side. So it's saying in data frame 2 there is no column called name. And so what we can do, though, is instead of providing a single value to our by argument, we can pass a vector of equations. And so it can be title is equal to name. And so that will actually work. This should be name equals title. Let me try that again. Name equals title. Okay, so that'll work. And you see we get our left join to execute, but this is the case where we got the duplicate Tom record. This was just like the first join we did up here with just by name. So we could add the additional, let's do it this way. Age equals years. Age equals years. And so there we get the last left join that we did where we join by both columns. Okay, so again you get the same output just by doing it this way. It's really this join here is exactly the same as this join. We just had the different column names, and so we can pass again instead of just the single unit column names being passed, we can pass a vector of equal statements. And then that'll operate the same way. We just have to associate the left-hand side column name with the right-hand side column name for each set of variables that we want to key on.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.